So these days, this crypto system is usually introduced, and it's an important application of this number theory these days. So let me explain this thing. This is called private key crypto system. This is actually very, very safe system, very difficult to break. However, people don't use that because its exchange of a private key is difficult. As long as you send this private key along the internet, it's no longer private key, it can be intercepted, and then you're vulnerable, right? But if you have exchanged this private key safely, then your exchange message will very, very safe. All right, it goes like this: 43 prime number. So I looked at the keyboard and wrote down basic lowercase alphabet and numbers and space and commas and some of the punctuation. I got 43 letters in there. I lined it up. Okay. So if you see number 4 in the text, it is converted to 35 and so on. So that makes sense? All right. And you have to exchange this private key. You actually have to meet and exchange this briefcase. What's in the briefcase is this 15 by 15 matrix. This size 15 is my choice. I just chose random case, right? So these are 15 by 15 invertible matrix. I created it randomly, all right? So that's the private key. And what we do is the following. This is the message. Looked at internet, got some message in there. T is 20 in that dictionary. O is 15. Blank 27. T 20 again. Makes perfect sense. Because T was 20 before, this T is a 20 again, right? Go all the way up to 15th letter. You truncate it. You make that 15 size of 15 into a vector over 15 size. And you keep doing that. If you're not even at the multiple of 15, throw in some gibberish words, make it into 15. Make sense? So turn that into a size 15 vectors. So I have a bunch of vectors in there. Next thing is that you have size 15 vector multiplied to the 15 size matrix, right? And then you get size 15 vector back. Now you change that to the words that you have dictionary, you have it again. So that's the word. And that was a 20 before. After you multiply that 15 by 15, it changed to 24. 24 corresponds to X and so on. So I changed that one into letters, and that's the one. Now you send that to the internet, and if you intercept it, it's not easy to break that. Now you receive it, you receive that message, and how you break that, you receive this message and block it into 15 because you know the size is 15, and you have this size vector 15 and multiply m inverse, right? And then that'll tell you what original VK is. Now you convert it to that. Good? Yeah. So with that exchange of a private key, the matrix is very, very safe. So I counted it. 15 by 15. There are 15 times 15 slots in that 15 by 15 matrix, right? And you throw in 43 choices in there. This is number of matrices out there. 15 by 15 with 43 numbers in it. Some of them are singular, so you have to remove it, but the magnitude is still there. So if you're going for that, knowing that it's a size 15, you go through this many cases and send it to Google. If it hits, oh, it's a word, oh, you hit it. Going through this many possibilities, right? That is the statistical attack that is involved in that one. Pretty safe. Very, very safe. All right. If you increase that 15 to 25, the encoding time is ginormously fast, but the probability, the cases you have to go through to crack this one is just 200 years, something like that. All right. All right. Exercise again. This dictionary is a 7 letters. All right. And you're busy. You grab that bag, went home, opened it. That was 3412. All right. So it's a 2 by 2, correct? The 2 by 2. So you have, I am the one who is sending, let's say that was a 6 letters. grouped it into two like that. I have a message and I convert it to this number and hit that by matrix and got another six numbers. Use that dictionary and translate into word. This is it, IIFTNF. You need to decode it. Okay, that's your exercise. First thing you have to do is that change this IIFTNF into numbers, right? And here's a chart. Then you will have the six numbers. Chop it into two blocks and figure out what the original message was. Yes, that's right. Yeah. Did I get this one right? I get 443653. IIFTNF, change it into number like that. Right, my inverse is 1, 5, negative 4, 5. You agree? It's switched around. You have to reduce the mod F7. Either this is 3 or that. So you agree? All right. Now you think about what to do with that inverse. All right, was that okay? Yes, it's finite. That's the word. Okay? That's exactly how the test problem is going to be. Like that size of that crypto system. Oh, believe me.